So today we're going to continue on with our applications of the law of sines and the law of cosines. So let's start with number 4 in the packet. Number 4, it says a 100-foot vertical tower is to be built on the side of a hill that makes a 6-degree angle with a horizontal. Find the length of each of the 2 guy wires that will be anchored 75 feet uphill and downhill from the base of the tower. Alright, so just like before, let's draw a picture. Here's the ground. We have a 6-degree angle. And then we have a tower. Make it a little thick here. Now the tower is going to have cables to support it. Let's see what else we know. Tower's 100 feet tall. And the length of each of the 2 guys wires, that'll be anchored 75 feet uphill and downhill. So this is 75 feet, and this is 75 feet. All right. So one thing we could do is we have that 6-degree angle. So what I'm going to do is I'm going to actually draw a line parallel to this 6. Like that. Maybe I'll draw it a little bit better. Something like that. If that angle's horizontal, that side's horizontal, that side's horizontal, they're both parallel, which means that 6 degrees is the same as this 6 degrees, which is the same as this 6 degrees. Those are vertical angles. This would be a 90-degree angle with a horizontal. So let's see what that whole angle would be. Looks like this whole angle would be 90 plus 6, so this angle right here would be 96 degrees. And that does make a straight line, so they're supplementary. So if that's 96, this would have to be 84, so we would have a straight line. All right, so now let's see what we could do. We're trying to find the length of each of the towers, or each of these cables. We'll call this X, we'll call this Y. Okay, so it looks like if we have, let's find X first. We have 2 sides, and we have the angle between. We could do law of cosines to figure out what X is. To find X, we would say that X squared is equal to 100 squared plus 75 squared minus 2 times 100 times 75 times the cosine of 84 degrees. And if we do that, that's the law of cosines. 100 squared plus 75 squared minus 2 times 100 times 75 times the cosine of 84. That comes out to 14057.1. And if you take the square root of that, you'll get the length of that wire is 118.6 feet. The other wire is going to be similar, but we have this whole angle is 96. We have the height of the tower is 100, and we have this other side length is 75. So in order to figure out the length of y squared, that's going to equal 75 squared plus 100 squared minus 2 times 75 times 100 times the cosine of 96 degrees. And if we do that, 75 squared plus 100 squared minus 2 times 75 times 100 times the cosine of 96. We get 17192.9. We take the square root of both sides. We get the length of wire Y is 131.1 feet. So it's kind of an interesting idea. That's how you would solve it. Let's move to problem number 5. Problem number 5, we have, we have Orlando is 178 millimeters due south of Niagara Falls. Right, so let's do it like this. Let's set it up. So on a map, we have Niagara Falls, and we know that Orlando is due south 178 millimeters. Denver is 273 millimeters from Orlando. Let's see, what did we say? Denver is 273 millimeters from Orlando. And Denver is 235 millimeters from Niagara Falls. It doesn't have to be drawn to scale here. All right. Find the bearing of Denver from Orlando. All right, so from Orlando, this is what we're asked to find. We're asked to find this angle right here. All right. Well, looks like we have 3 sides and we don't have any angles. So the way that we talked about doing a problem like this is we have to use law of cosines, and generally we find the largest angle first, which would be the angle of Niagara Falls. So the cosine of the angle of Niagara Falls would equal, remember your formula for an angle. Cosine of an angle is equal to, b squared plus c squared minus a squared all over 2bc. So it's the other 2, right? So this is how we're going to set it up. So this is the side opposite Niagara Falls, 273. So it's going to be minus the 273 squared. And we're going to have the other 2 sides, 235 squared plus 178 squared. And on the bottom, it's going to be 2 times 235 times the 178. Let's see what that is. 235 squared plus 178 squared minus 273 squared is 12,380 divided by 2 times 235 times 178 is 83660. And if we take the inverse cosine of that, the angle of Niagara Falls let's see here, 12,380 divided by 83660, and the inverse cosine of that is 81.5. If that's 81.5 degrees, we could do 273 over the sine of 81.5 is equal to 235 over the sine of whatever the Orlando angle is. And if we cross multiply and divide, 235 times the sine of 81.5 divided by 273, and if we take the inverse sine of that, we'd get 58.4 degrees. So as far as the bearing from Denver to Orlando, it looks like we would have to go north, and then we would go 58.4 degrees west. And then for point B, or part B, it's asking to find the bearing from Denver. Let me see. Denver from Orlando. So let's see here. So I wrote this here. Let's say Orlando to Denver. That's really what it's asking you for, and that's what it would be. And then for part B, it's asking us to find the bearing from Niagara Falls to Denver. And I think we already did that. We're going south, and then 81.5 degrees west. All right, so that was part 5. And we'll do 6. It says we have a baseball diamond. All right, so I know some of you baseball and softball players here. Oh boy, that's really bad. All right, that's the best it's going to be here. So we have a baseball diamond. Here's first, second, third. All right, a baseball diamond with 90 degrees or 90 foot sides. The pitcher's mound is 60.5 feet from home plate. How far is it from the pitcher's mound to third base? All right. Now, one thing that I wasn't aware of with this is that we assume that these angles are 90 degrees. That's just how it is with baseball and softball. That's what it is. All right. So here we go. All right. So let's see what else we could figure out from here. If we know that, all right, so the pitcher's mound is directly up. It cuts this angle in half. That angle, all of these angles are 90 degrees. So that's something that I'll tell you. I didn't know that when I was doing this problem. I had to research it. The bases are 90 degrees, okay? So maybe you guys knew that, but that's one thing. So this angle would have to be 45 degrees. And we're trying to figure out this distance to third base. Well, we don't have a full fraction if we were going to try to do the law of sines. But what we could do is we could use the law of cosines. If we label our triangle A, B, C, the distance we want to find is B, right? What we could do is we know angle B, we're looking at this triangle. Well, using the law of cosines, we would know that B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. A squared would be 60.5 squared. C squared would be 90 squared minus 2 times 60.5 times 90 times the cosine of angle B. Let's type this in and see what we get. 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times the cosine of 45 gives us 40, 59.85, whatever. We always round at the end, not in the middle of the problem. And if we take the square root of both sides, we'd get 63.7 feet is the distance from the pitcher's mound to third base. All right, So for homework, what I would like you to do is please try numbers 10 through 12. I will see you tomorrow. Have a nice day. Good luck.